Hello and welcome to second webinar of OptiBlend. My name is Sunil Kumar. I'm Vice President of Product Engineering at Systech Solution. And joining me is Dr. Satya Jayadev. He is a Principal Data Scientist at Gyan Data. He did his Master's and PhD from IIT Madras and specializes in the area of data-driven modeling and analysis and optimization in control systems using machine learning. Just a quick recap of what we had seen in the first webinar of the OptiBlend, where Professor Shankar has introduced the concept of optimization on a blending process. And we also have looked at the industrial use cases where it could be really be applied. Today we'll be doing a deep dive, technical deep dive of the product. We will show you the demonstration of the product with a couple of examples. But just before we get in there, I wanted to kind of give you a kind of like a overall view of how this OptiBlend platform is actually been architected. So beneath that, if you look at it, it's actually is based on a complete data analytics and analytics platform called Doppler. It's actually built on top of an analytics platform called Doppler, which has its own storage and then data warehouse and a BI and AI, and has a machine learning complete flow ML ops per se. And on top of it, if you look at that, we have the complete OptiBlend product, which is actually, it's a kind of like a three-step process where we first do the data acquisition, which is the data processing, and then you see there's a blend modeling process, and then finally comes the optimization. In each of these sections, we have some obviously the industry or probably use case specific customization that could be done, and that we will be seeing it today. Just wanted to focus on the first part of it, where the data source, where the data acquisition can happen at multiple and variety of places. Like, for example, if the data is originating from a SCADA system, which is an IoT system, it can be directly be plugged in from there to pull the data from there. If it is in a database or a flat file, all those connectors is also available that can be used to acquire the data and then go through the process of these three-step process for doing the OptiBlend process. On top of it, we have obviously a complete OptiBlend user interface, which is actually making the whole platform very simple and easy to use for even end users. So you do not actually need to know a lot of details about exactly how the blending process or the modeling happens. You will be able to configure that from the GUI tool that is there, user interface that is there at the top, and you should be able to build the sophisticated optimization process all for the use case. So I want to hand it over to Satya now, and for him to take through the product and show you exactly with a couple of use cases. If time permits, we can go for two, but if not, then we'll just use with one. So over to you, Satya.
Yep. Thank you, Sunil. So good morning, everyone. So as Sunil mentioned, I'll be taking you through a demonstration of the OptiBlend product, in which we'll try to discuss two use cases depending on the time. Before we go into the product demo, I'd like to give an overview of the use cases so that you get an understanding of how we are formulating the problem and then using OptiBlend to solve it. So these are two use cases which we have implemented on OptiBlend as POCs. So the one use case comes from the pharma industry, where we try to blend ingredients, combination of an API and multiple excipients to produce powder, which will be eventually used to produce a tablet. So in this particular use case, the raw materials include one API, which is ibuprofen. It's a sort of a pain reliever. And there are multiple excipients, which include MCC, which is a filler and binder. There's lactose monohydrate, a diluent. There is sodium CMC, a disintegrant, and then magnesium stearate. It's a lubricant for tablet. So these are all the different raw materials, or basically the ingredients that are getting blended to produce the powder for tablets. And in this particular use case, we were considering the properties such as bulk density and PSD, which is particle size distribution of all these raw materials. Okay. And so this is what we are particularly interested on the input side of the blend. So coming to the output of the blend model, we are interested in the properties of the tablet powder, such as blend uniformity and flowability. Of course, this is specific to this use case. We can consider more properties on the raw material side or more properties on the powder side as well. I mean, there are no such restrictions as. Okay. So this is what we have considered in this particular use case. That's it. So visually, this is how it looks, where we take all these 5 raw materials in different proportions, mix them to produce a blended powder. Okay, so this is how the blending process happens, and this information we are going to consider to perform blend modeling as well as blend optimization. Okay, so I'll come to that part in the demonstration, but I'll also walk you quickly through the second use case which we have implemented, which is a use case of olive oil blending. Okay, so we have implemented this particularly from the consideration of a food industry client, but this has a wide range of applications in pharma as well as cosmetic industry. So in this use case, the idea is to blend different varieties or grades of olive oil to produce eventually olive oil again, but having desired characteristics. So this is a slightly contrasting use case compared to the first one, where the input and output are significantly different. While here, input and output are more or less of the same type, right? It's olive oil both on the input as well as the output side. So the properties that we are considering on the raw material side as well as the product side are actually the same. Okay. Only thing that is different is we are considering multiple varieties of oil and all their corresponding properties on the raw material side. And based on that, we build a model to predict the same properties of the blended olive oil, and then use this model to perform some sort of optimization. It could be a cost optimization, it could be some sort of quality optimization, or any such thing is possible. Okay. So these are the 2 use cases that I'm going to demonstrate on OptiBlend. So I'll right now jump into the application itself. Just give me a minute. I'll share the application screen. Okay, so I hope my new screen is visible to everyone. So as you can see, this is a complete SaaS application, as we have mentioned in the last webinar as well. And Sunil also gave an idea of how this whole thing is built up at a high level. So this comes in with a username, password. As you can see, I'll just enter my username password. And once we log into the application, here, you will see a screen which shows you something like a set of projects, right? So basically, I'll kind of explain what we mean by a project. So every blend process that we are going to consider, we'll take it as a separate project in this particular case. So whenever I want to create a new project, it's a very simple this thing. As you can see, I can just click on this. I'll go to the actual this thing, but just to demonstrate how this thing, I'll just say test project. Okay, you can give a project description if you want. That's not mandatory. So once you create this project, it takes you inside the particular screen, which is the projects, right? So all the tabs that you see on the left-hand side, these are all the different components that are available within a project, right? So we have blend configuration, blend modeling, and blend optimization. So I'll go through each of these 3. The first most important thing to be done is the blend configuration, right? Where we basically decide or tell the system what are all the input raw materials, or we call them as streams in general. Okay, what are all the different input streams? What are the proportions in which, proportions come in as data? What are the properties of each of these streams, and what are the properties of the output? Okay, because this is a completely general application. This is not customized to any specific use case. So you can build your own use case. So as I already discussed 2 use cases, so I'll show you one. So in this particular case, the simplest way we are doing it is we simply upload a file. Okay, let me quickly select the files. and upload them. So all the data sets, you can upload multiple data sets in a project, and all the data sets that you're going to upload, they'll be associated with a particular name. So system asks you what is the name that with which you want to associate this whole data set. So I'm just going to upload. So when I upload, it will quickly check out the data, whether it is having a suitable format. It will also check whether the row counts are all, here you can see all of them have same row counts, which is important, which means the samples in all the different files are same. So one file is basically containing all the proportions data. One file is containing all the raw material properties data. Other is containing the output properties data or the product properties. Okay. So if I click on this, you will see a preview of what I have just mentioned now. This is the same use case which I discussed earlier. So in this, you see these are all the proportions, right? So basically they add up to a factor of different proportions. And here you will see this ibuprofen, MCC, lactose, sodium CMC, magnesium stearate, right? So, and similarly here also you can see this ibuprofen bulk density, MCC bulk density, lactose bulk density. And then for the particle size density, we are just considering the median value, okay, just for simplicity. Of course, you can take it into more complex considerations as well. So this shows the median values of each of the raw materials. And on the output side, we're just taking two properties, blend uniformity index and blend probability. Okay, so this is just a preview of the data. Though there are 300 samples, here you can just see a preview of just 5 samples. Okay, so now this is where the most important part of mapping happens, because the system doesn't know which property corresponds to which stream name, which we want to capture. So basically, when I select ibuprofen, I need to tell what are the properties that are corresponding to this particular. So here, basically, I select ibuprofen bulk density and ibuprofen 350. Similarly, if I go to MCC, I'll be selecting the corresponding properties of MCC. And then lactose monohydrate, I'm just calling it lactose for simplicity here. So then there is sodium CMC, which you can select. And there is one more, this is magnesium stearate. Okay. So these are all the different things. So now once I try to save the configuration, before saving, it will actually give me a preview of what we are actually saving, right? So it shows me what are all the raw material streams, what are the corresponding properties that we have mapped to each one of them, and what are all the also the output properties. So it captures all of this from the files itself. Right? Basically, you're not entering anything of this. We ensure that so that the names are not kind of manipulated, or any wrong name can cause issues in how the whole system is working. So we prefer that the files, the data comes through files, or of course, as Sunil has mentioned, we can support other things like databases or other things there. We'll try to do it in a slightly different way. But this is the simplest way, where you can simply upload files and set up your blend configuration and then confirm this. Okay. So one thing is, there is no necessity that each and every raw material should have a corresponding property on this side. It's only, say, in some cases, maybe something like water is also one of the raw materials, and then there aren't any specific properties of water that you are interested in. Okay. In that case, only the proportion of water is considered, while the properties are not relevant. So that is also a possibility. So we are not mandating that every stream name should have a corresponding property in which we are interested. Okay, but in case there is a property of interest which has an impact on the output, all those properties should be considered. Okay, so this is where the formulation comes in. So before you are able to enter all this information, the formulation should have been done. Right? What are all the raw materials? What are the corresponding properties? And what are the properties of the product? Okay, once that is decided, from then on, we can start using OptiBlend to do all of this, and it will hand the rest of things by itself. So once I click on confirm, so I'll go back to this page. I mean, it will redirect me to the next page, but I'll just show here, right? Now, if I come back to the blend configuration page, it shows me all of this. So whenever I'm saying a project, it is this part of the blend that is fixed for a given project. So the configuration of the blend is fixed for a project. I cannot change the configuration for a project once it is fixed, right? You can upload multiple data sets, you can build multiple models, you can do multiple types of configurations, optimizations and all of that. But the blend configuration, which means what are all the raw materials streams, what are all the corresponding properties, and what are the properties of the output product. So this is fixed at a project level. Okay, so if you want to change anything in this, you should be actually creating a new project. You cannot do it in this. Okay, so the system will actually not allow you to change any of the configuration once it is saved. Only thing you can do is you can delete this project and go for a new one if you did something. But the main idea is, so everything is basically linked to this configuration. The data that we are going to upload, the models that we are building, the optimization that we do, everything is linked to this configuration, which is why we keep this as a constant throughout the project. Okay, so I hope you got an idea of why we are doing it in this fashion. Now I'll go back to the home page where I see the project. So the new project that I have now added, I can see coming up here, the test project. But now I'll directly take you to the projects which I've already created. One for tablet blending. Okay, I already added some description, which you can see here. So I'll jump right in. Here, directly it will take you, because I built some models already, it will take me to that. So, but otherwise here you can see the same configuration I have created. Now, let's come to the blend modeling part. So in blend modeling, you can actually see five different tabs here. One is model training. Another is model predictions. Another is model management, data upload, and data management. So in model training, this can be basically used to train your models. So where you have to simply select a data set. So it will show you all the data sets that have been already uploaded. Right now, there is only one data set that I uploaded in this project. And it will also allow you to select a regression technique. By default, it will select a technique which we call AutoML. Okay, so people who are familiar with the ML framework, they might be knowing what is AutoML. Basically, AutoML is an automatic way of choosing what is best to the given data set. Right? What is the best technique to be used to build a best performing model on the data set? So here the system automatically does a lot of iterations in the background and gives you the best model. So you are leaving it to the system to decide what is the best technique and the best model. Otherwise, you can choose also, if you want to go with any specific type of a model, you can choose that particular model. So we are supporting all these types of regression models: linear, ridge, lasso, random forest, KNN, XGBoost, and so on. Okay. So, and every model that we are going to create, it takes a specific name. So you have to create that name. Okay. And it will also ask you how you want to evaluate the model. Ideally, you can choose a test set from the existing data, or you can upload a different separate test set. And here you can either go with a 10% or a 20%. So among all the samples, 10% or 20% of the samples will be used to validate the model. Okay. So this is the process. I'll directly take you to model management. So once a model is actually trained, okay, it takes some time to train a model. Maybe let me also quickly show a run to you. Okay, let me just take, say, something like linear regression. Okay, I'll call this as blend model underscore LM. Okay, I'll just say train and evaluate. So it'll just take a few seconds for the training to begin. It'll ask you to wait for a few seconds. And once that is done, it takes you to a next page, which is the model management page. So here you can see that the models which are already trained and which are still undergoing training are all listed in this place. Right? Because sometimes, depending on the size of your data and the complexity, or sometimes AutoML also takes slightly longer amount of time to create a model, which is why you need not wait here. You can even basically close the whole thing and leave it to OptiBlend. It will keep running in the background. And once the model is ready, if you come back, say after a few minutes or after a few hours, you'll see that your model is ready to do whatever you want. You can start making predictions from it. You can start using it for optimization and all of it. Okay, so here you can see the model which I just started training. It's still undergoing a training process, while two models which I already created in the past are already available. So I'll just show you. So if I click on an AutoML model, it will kind of give me an overview of by whom it was created, when it was created. Okay, all again basic input and output properties. So, but the most important thing that's of interest is what is the model performance. So here also it will show what is the error in prediction on the test set that was considered for this particular model. So yeah, this is where you can see all your models and their performance. And then we also have options to upload data and manage all the data files that are uploaded. I mean, this is basically a very simple interface where everything is accessible and managed. You can even download the data sets that you have uploaded in the past, okay, and do all of this. Now coming to the last part, which is blend optimization. Here you have to basically configure your this thing, right? Because you need to tell the system what is the objective function. Okay, what are all the coefficients to be used in the objective function? What are all the constraints and all of that? So I'll directly show you a configuration which I created. So this shows you how we set up a configuration. So this is just the name for the configuration. The configuration is linked to a particular model, right? Because whenever you do an optimization run, it uses this model to predict the outputs. And then you have an objective function, which for now we are only supporting linear objective functions, but in future we plan to support nonlinear functions as well. So here, the coefficients of the input stream ratios are being considered here. So this is basically like a cost that you can associate, like a per unit cost. Say ibuprofen costs about 5,000 rupees per kg or something like that. So here we are not putting any particular unit. So we just say per unit. You can either take it rupees per kg or dollars per kg or rupees per ton, whatever you want, right? And accordingly, the final value that is given by the returned by the system will tell you the overall cost according to the unit that you chose. And here we select all the lower and upper bounds for all the proportions and lower and upper bounds that are desired for the output stream properties as well. So because I already created this thing, it will not allow me to change anything here because I already ran some optimization runs over this. So I'll take you to the run optimizer page. Then this is where you can run the optimizer multiple times. You basically have to select a configuration. It will ask you for some input values, right? So for this optimization run, what is the value of, say, bulk density of ibuprofen, median value of ibuprofen, and so on, all this. You simply, once you click on optimization, there also it takes you to a results page, right? Because this optimization run can also take some time. And here we can see that once the results are ready, it shows, I will show you one of the results here. It will show this. I mean, after running the optimization, this is the value of the objective function. These are all the decision variables. So these shows the proportions of each of these. And this one is the output side. Okay, what is the expected value of the output when you choose those proportions? And it shows that the expected values are within the bounds that were given in the optimization part. Okay, so all this is happening through a very simple user interface. And as you can see, everything can be managed through these. So, I mean, because this is a very short webinar, I gave you a high level details. So if you are interested, we can always have a detailed discussion over more of these features. And as I mentioned, we also have user management and organization level control as well if there are such requirements. So anyway, I'll not go into these details now. So this is the first version of the product that we have, and we are continuously developing it further, adding more features in the coming days. And we are also open to taking feedback as to say if there are specific features which clients want, we are open to adding them as well. So with this, I'd like to pause my this thing and open the floor to questions that people might have about this product, and we'll try to answer. So
okay, thank you, Satya. That was really engaging. Hope that has really helped the audience to understand the length and the breadth of the product and how useful it is and how easy it is to do the optimization and a kind of like a GUI interface like OptiBlend. So we have a couple of questions. I think the first question is that, is there any limitation on input data volume? Can OptiBlend handle huge amount of data, say more than 5 GB? There is no per se as like there's no as such there is a limitation that we have put it on the product. The deployment of the product is pretty horizontally scalable, and even if there's a huge volume of data, we should be able to ingest it, and we should be able to create the models on top of it, and then do an optimization as well on top of it. But any specific use cases that you might have and the kind of data that you have, we can always talk regarding that further, and look at specific cases for you. So hope that answers your question. Second question is that what if we already have a physics-based model, or if we want to use a customized model for an optimization? So do you want to take that question?
Yeah. So right now, as you see, we are building models using data that is provided to OptiBlend. But in the next version, we are planning to support the customized model, right? An interface will be added where we can upload an existing model, or maybe we can also provide an interface where you can kind of enter something like a linear model easily, right? Because so certain models are already known, and then we don't want to build a model out of scratch again, and we can directly go for optimization. So we are planning to support customized models and even physics-based models in the next versions of OptiBlend.
So one more question is that, is there a way we can try the product? Absolutely, we can try the product. I would suggest you guys get in touch with us and with our sales, and we will be able to demonstrate product one more time for you for your specific case. We can talk about it, and also we can in fact probably tailor or probably kind of get into an engagement where we can do a kind of a POC or POV for your case. So certainly we can definitely look at the product, maybe one more specific in the case of your customer. One last question is that, can OptiBlend handle multi-objective optimization and nonlinear objective of functions? Satya, you want to take that?
Yeah. So about nonlinear objective functions, as I mentioned, since we are trying to do all of this using a GUI interface, we are seeing what is the best possible way to incorporate nonlinear objective functions, because most of the nonlinear objective functions that say people handle in optimization, they are done through programming interfaces. I mean, most of the other products handle them through programming interface. So here we are trying to see what is the best way to do it in a GUI interface. So that's already in the pipeline. At least we'll try to support nonlinear functions which are standard in their structure, like certain exponential or logarithmic functions, which are very much standard, and then only the coefficients of the function change, right? So that is something that we are planning to immediately support in the near future. And coming to multi-objective optimization, here we need to see what exactly you mean by a multi-objective optimization. I mean, whether say the objectives are conflicting or complementing each other. And right now we are supporting only one objective. Say if a multi-objective can be converted into a single objective problem, then that still can be solved using OptiBlend. But if there are any specific scenarios, we are open to discuss and see if we can incorporate multiple objective features into OptiBlend. Okay.
Okay, all right. So I guess there is no more questions. In case if you have any more questions, please feel free to even post it to us. We should be able to get in touch with you, and we can probably explain it much in more details. So I think this concludes our session today, and I hope it was useful for you, and we would look forward to see if you have any more feedback for us, or if you want to engage in fact in any of the custom cases that you might have. We would be happy to take that as well as one-on-one, and then we'll be able to look into that in more specific scenario, and probably getting engaged with kind of like a quick POCs and or a full-fledged engagement. So with that, I thank Satya for your time, and thank everyone for your time that you have been spent with us today, and looking forward to hear more from you guys. Thank you.
Yeah, thank you everyone.